I am Anil Kumar. Welcome to my series on exponential functions. Here is test number 1. Let me thank my students for sharing such test papers. We'll have 11 questions rather in this test paper. Let us first go through these questions and then we're going to answer them one by one. So we'll begin with very simple concepts of evaluating the radical numbers, solving a simple exponential function. So there will be another video on exponential functions where we'll treat more complex problems related to exponential functions. Then we'll simplify such expressions. We'll write domain and range of transformed functions. We'll describe the transformation. And given the function, we need to figure out what is the image point on the transformed function, correct? And then we'll take up questions related to sketching the graph of a transformed function, writing equivalent expressions by changing the base. And then we'll have an example on how to write exponential function from the given graph. And then we'll have 2 application questions. So that is how the test paper is structured. Now let's look into these solutions one by one. Evaluate 64 to the power of 3 over 2. So you could do it in different ways. One of the simplest way could be, this could be written as 64 and 1 over 2 is basically square root, right? So we can do square root first and then we can cube the function, correct? So square root of 64 is 8. So we get this as 8 cubed, right? So 8 basically means 8 times 8 times 8, right? So multiply, we'll get this as, we can write this as 8 times 4 as 32, 2, 3. 8 times 6 is 48 and 3 is 512. Is that clear to you? Right. Okay. Now, sometimes we could ask this change base to 2 and then evaluate. So let this be question number 1B for you. Is it okay? Change base to 2 and then evaluate, right? Okay. Now let's take the next question, which is solve 3x equals 27 to the power of 1 over 3. So cube root of 27. Now that really means we are writing 3x is equal to, negative means 1 over, right? So 1 over cube root of 27. So cube root of 27 is 3, right? So it is 1 over 3. So the value of x from here we can calculate as 3 goes in the denominator, so we get 1 over 9, correct? So that becomes the solution. Perfect. So for us the solution is x equals to 1 over 9. The next one is to simplify this kind of so exponential laws we are working with. One mistake which sometimes students will do is will not cube 2, right? So you have to write 2 cube also, right? Do you understand? 2 cube. The next number is a2 to the power of 3. When you multiply by 3, we get this as a square. And then b becomes b square. In the denominator also this works. So we have a cube. We get b to the power of 2 times 3, 6, but with a negative sign. Is that clear to you? Right? Now, as you can see here, the powers of 2, we could actually cancel these 2. We are left with 1 here, right? But this goes in the numerator. Perfect. So what I'm trying to say here is that you could write this as equal to 2 to the power of 3 is 8. And we have b to the power of 2, and this is minus 6, so it becomes 2 plus 6, right? Let me write like this, over a. Now we should be writing our solution with positive exponents, that's the whole idea. So I'm not writing a to the power of minus 1. So let me write this as 8, and here we get b to the power of 8 over a, and that becomes the simplified form of the given expression. Clear? Question number 4. Write domain and range of this particular function. Now, minus means, let's think about it. So minus, this minus means reflection on x-axis, correct? So that means the graph is going downwards, and this the negative one means that we have a horizontal asymptote y equals to minus 1, right? So y equals to minus 1. Now these two informations are good enough to write the domain and range for the function, right? So if you want to sketch this function, then this function will be, since this is a positive, more than 1, 3, right? So what we get here is a function which will be kind of going like this, right? Where we have a horizontal asymptote which is y equals to minus 1. Is that clear to you, right? So as far as the exponential functions are concerned, the domain is all real numbers, so no problems there. So we can write x belongs to real numbers, right? As far as the range is concerned, there is a restriction, and now we figured it out. We get y belongs to real numbers where y is less than minus 1. Is it clear, right? It is approaching minus 1, but it is not quite there. Okay, so that is how you're going to answer this. Question number 5 is to describe the transformations. So to describe the transformation, important thing here is to rewrite the function with factoring out this number 2. So we get 3, 5. Factoring 2, we get x plus 3. Do you see, realize that part, correct? So that is how first step should be taken. And then you should start writing your transformation in order, right? So order should be what? Order is from left to right. If you do that, you do multiplication first, then you do plus or minus, right? So multiplication, division first, that is the order, right? So let's write down each transformation one by one, right? So first one here is vertical stretch by a factor of 3. So we have vertical stretch Okay, the second one here is horizontal compression by factor of half. One over 2, and this 3 means translate 3 units which side? Left, not 6, okay, and that means 4 units up, right? So we have translate 4 units up. So I hope that is absolutely clear, right? Now let's take the next question, which is question number 6. Given the function f of x equals to 2 to the power of x, write the image of the point 38 on the given function, right? So we are given the function f of x equals to 2 to the power of x, and the point here is 3. So if I write 2 to the power 3, I do get 8, right? The other one, g of x, is given to us as 0.5, means half, right? Times 2 to the power of minus. I'll factor out 3, right? But minus 3 this time. So I get 6 divided by 3 as 2 plus 4, correct? So any coordinate which is x and y here on the function, it gets transformed to what? Write this first, right? So x value will get multiplied by minus 1 over 3, right? That is what happens to x value, and then you take away 2. As far as the y value is concerned, it gets multiplied by half the original y value, and then you add 4, right? So these two x values. We have 3 and 8. So if I substitute this with 3, I get minus 1 over 3 times 3 minus 2. And we get half of 8 plus 4. Correct? Do you see the calculations, right? So we get minus 1 minus 2. And here we get 4 plus 4. And so we get our coordinates, which is minus 3. And we get 8. Right? So the y value is still the same. And the x value is this, correct? So that is our answer. So the transfer point is The image is what? Minus 3, 8. Is that clear to you, right? We need to sketch graph of g of x, which is equal to minus 2, f of half x minus 2 plus 4, where f of x is 3 to the power of x. So I'll actually sketch a rough graph. You should do it on a graph paper. Now, to sketch this graph, we should understand the transformations. So we are going from 3 to the power of x to a transformed function, which is minus 2 f of. So here we should take half common. So I'll rewrite this as half of x minus. So it gets multiplied by 2. We get 4. And here we have plus 4. Correct. So this is the function, and that is the transformation. So in this case, how will the coordinate points change? So if I have x, y on the graph of 3 to the power of x, then the value of x will now change. It will get multiplied by 2, right? That is horizontal stretch by a factor of 2. So we get 2x. And this point here will shift 4 units to the right. So plus 4. Note that if I would not have taken this common, some students could make a mistake of writing 2 instead of 4. That would be wrong. And the y coordinates will be minus 2 times the original value. So we can write this as x0, y0, the original values, right? So minus 2 times y0 plus 4. So it is reflected on the x-axis and move 4 units up. Correct? So our graph basically, you can see, is going downwards now with horizontal asymptote at 4. So more or less we got an idea. Now to make a better graph, what we should do here is take some values, right? So let's take some values. We'll take few critical values which can help us sketch a good graph. So let's call this as function f of x, and the coordinate points will be x0, y0, right? Now here we will write down the transformed points, right? Okay. Clearly the transformation is shown here. Let me rewrite this. So to each value of x we'll multiply by 2 and then we'll add 4, correct? As far as the y is concerned, we'll multiply by minus 2 and then add 4, right? So that is the kind of transformation. Now one of the important points here is 0, 1. So if I use 0, the y-intercept is always 1. That is to say 3 to the power of 0 will be 1. Now this point get transformed. So 0 times 2 is 0 plus 4. So we get this as 4 here, right? And y value of 1 means minus 2 plus 4, which is 2. So we get a 0.42. Now next important point to consider is the asymptote itself, which is when x approaches negative infinity. So we can say when x approaches negative infinity, in that case y approaches 0 from above, correct? That is the horizontal asymptote. Clear? Now in this case, what am I saying? I'm saying negative infinity, that will remain negative infinity, correct? So when x approaches negative infinity, plus 2 times that, it remains negative. But the y value becomes negative. You see that? Negative means it's going downwards, right? So, and we are adding 4 to it, right? So we are adding 4 to it. So it approaches 4, but from below. Do you see that? That's negative, right? So 4 from below. So this is a very critical point. And of course, in any exponential function, let me write here, if I approach positive infinity, then y also approaches positive infinity, right? So in this case, the x value approaching positive infinity, the y value, since it is negative, approaches negative infinity. Does it make sense to you, right? So that is one important thing. We could take two more points here related to the value of x as 1 and minus 1, right? So if I take 1 as the x value, 3 to the power of 1 will be 3. On this side, 1 times 2 is 2 and plus 4 is 6. And as far as 3 is concerned, we get minus 6 plus 4, which is minus 2, right? So we get 1 point here. And here if I write minus 1, I get 1 over 3, right? Which is difficult to calculate anyway. Minus 1 gives me here minus 2 plus 4, which is 2. And the value of y will become plus 2, 2 over 3 minus plus 4. So 4 minus 2 over 3. So 3, 1 over 3 you can say. Okay. So 2 over 3 if I take away from 4, so we get 3, 1 over 3. So these are good enough points to sketch the graph. Perfect. Okay. So we see that the graph is actually going downwards. So I will use most of the points are on the positive side. So in this limited space, what I'll do here is sketch like this. So one, clearly we do have a horizontal asymptote at 4, right? So let's say this is 4 for us. So that really means that we are approaching like this, correct? And then we have a point 2, 3. So on this side, positive side, 4, 2, right? So on this side we have a point 4, 2. Then we have 6 minus 2. So let's say this is 4, then that is 2. And let's say this is like 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we have a point 4, 2. 1, 2, 3, 4, and 2. That is 4, 2 for us. And then we have 2. At 2, we have 3, 1 over 3. So at 2, slightly more, kind of like this. So we will be approaching this part. At 6, we have minus 2. So at 6, we have minus 2, right? So, well, that could be better estimator. So we have our points here to sketch. So let me just go like this. Connecting these points with a smooth curve, we get our graph. Is that clear to you, right? So that becomes the exponential function, which is g of x. Is that clear to you, right? So these are the critical points which we should mention, which are 4, 2. Here we have 6 minus 2, and we have 2, 3, 1 over 3, okay. And this is 4, right? So we have a horizontal asymptote, which is y equals to 4. Is that clear to you? So that is how you could sketch the exponential function, transformed exponential function, where the base is 3. So I hope it makes sense. Question number 8 is, write an equivalent expression to each of the following function using the indicated base. So f of x equals to 2 times 9 to the power of 2x minus 1. We have to change the base to 3. So we can write this as f of x equals to 2 times 9 to the power of 2x minus 1. Let's change the base to 3. So we get 2 times 9 is 3 squared, right? So 3 squared to the power of 2x minus 1. So we could write this as 2 times 3 to the power of 2 times 2x minus 1, which is 2 times 3 to the power of 4x minus 2. Is that clear to you? So that is how we'll change the base. The next one here, we need to change the base to 2. So we could write this function f of x as equals to 3 times 1 over. Now 2 to the power of 4 is 16, right? So we get 1 minus x. Now this could be written as 3. Now we have 1 over 2 to the power of 4 times 1 minus x, right? So which could be written as 3 half. And we get this as, let's open the bracket, which is 4 plus x, 4 minus x, 4x. Is that clear to you? However, the base has to be changed to 2 and not half, right? This is important. So we have to flip this. So basically we should be writing like this, 3, 2, and that becomes negative of 4 minus 4x. You understand, right? So the final answer should be written as this. So this gets minus, that gets plus. We could write this as 4x minus 4. Does it make sense to you? So that is how we are going to write this particular answer. Perfect. Now let's take a small break and then we'll take up application questions.